Everybody. So, yeah, welcome to week 4, lecture 2. Today, we're finally going to learn how to have a variable that can contain like someone's name or some text or something like that. So we can have more than people's initials for their names and things now. Well, not now, once we get to the end of this. All right, so hopefully you're getting on top of one-dimensional arrays. Maybe, hopefully. How's everyone going with one-dimensional arrays? Actually, can we do a poll of 1D arrays? All right, we'll do a bit of a recap of 2D arrays today. And then we're going to talk about strings, a little bit on arrays of strings, and then command line arguments. Now, anything we don't finish today, even if it's in the slides and we don't finish, don't panic. That doesn't mean I'm just going to leave you to yourself to work it out. I'll go through it in the next lecture. Okay, so I've got a little bit of feedback sometimes that people are worried I'm not going to show it later, but I will. I'll go through it the next lecture. All right, as always, we've got, everyone's excited about the assignment, right? I can tell that's what you're all talking about. Yeah, link to the week 4 live lecture code. Hopefully I've made it available. And you all know assignment 1 has been released. Hands up who's watched the live stream. So there's a live streamed, well, there was a live streamed event. It's recorded. So if you look on the assignment spec, there's a link to it. So it's good to watch that before you get started. So John did a great job of walking through it and, helping people get started. All right. So do that and then fetch the code and get started as soon as you can. All right, and yeah, that's all I'll say. Hands up who's been to revision sessions. There's been 2 this week so far. There's still 1 more today at 12 o'clock. Oh, not today, tomorrow. I don't even. Is there one today as well? Oh. Yeah, tomorrow, I'm looking at the slide, it says Friday, and I'm saying today, all right. So we're gonna have a good lecture, everyone. Friday, tomorrow, there's a revision session tomorrow. And there's a whole heap of help sessions on. So if you're not sure where the links are or how to access any of these stuff, ask us in the YouTube chat or ask us on the break or something, we can help you. All right, so Monday's a public holiday. So hopefully everyone's looking forward to having a lovely long weekend. Is anyone doing anything fun? So that's a yes, you are doing something fun, assignment 1. Yeah, okay. All right, so that means on Monday we miss our lecture, but don't worry, I'm recording a video. So I'll put it up before Monday at the latest, hopefully. I'll put it up as soon as I do it. Yeah, it's going to be fantastic, but it's going to be a bit of a recap of what we do today. And then the focus is a sort of a larger example, a larger coding example than we typically have time for in lectures. And it's putting everything together. So it's putting together 2D arrays of structs with enums in it, which will be helpful because of what? Where else do you have to use a 2D array of structs and enums? Yeah, in the assignment actually. So it's putting together a lot of the skills you'll need for the assignment. It's not doing the assignment, and it's not doing a problem that's exactly the same as the assignment, but the astronauts changed to a mouse getting cheese or something. But it has all the same sorts of stuff you need to know. And we'll have a little small, very small topic just about how we can work with multiple files in a project. So we've been doing everything in the 1C file, and we're going to continue to do that for assignment 1. But for assignment 2, we'll be splitting things up into different files, so we'll be talking about that. The other thing is, if you're in a Monday Tute lab, yours won't be running on Monday for the public holiday. So there are links, and this was also announced on the forum. There's a link to book, COMP1511 would be the access code when you click on this. I didn't actually even mean to click on it. But there's a link here and in the Ed forum. You can book into a Tute lab that's on at a different time and just attend it for this week, all right? Or next week. Just so you don't miss that content, especially around assignment time. It's really important because it's going to be covering a lot of concepts that will be important for the assignment. It also means we've got a different Lab 4 deadline. So usually our labs are due on Mondays. Monday's a public holiday, so it's going to be due on Tuesday. Just this once. Don't get confused and think forevermore they're due on the Tuesday. A few people did last term, I believe. All right. Oh, did we do a poll on one-day arrays? Okay. Well, look, I might, before we launch into 2D array recap, I might do the quick Kahoot now on the 1D arrays to get people, I don't know, just to remind us and to get our brains started up. Get my brain started up. So yeah, we'll just do a quick Kahoot. 1D arrays, mostly of ints, but one struct question. And then we'll get into a recap on 2D arrays. And just while we're waiting for another minute to join, did anyone have any questions about public holidays or revision sessions or help sessions or any of that sort of stuff while we're waiting? Everyone's okay? Yep. Oh, so how do the revision sessions work? There's a bunch of revision exercises, and they're kind of like lab exercises, and you can either go through them and do them sort of more independently with help, or you can sort of have it in a more tutorial style. It's up to you, I think, when you get in there. There'll be 2 tutors doing one of each kind of style of thing, depending where you're at. Yeah. Right. Okay. Let's see if people. Any other questions? And yeah, the help sessions aren't really busy yet, but they will be in week 6 and week 5. Yes, they'll start getting busy. All right. Let's get started. Anyone here trying to join that isn't joined? Okay, let's go. And you guys miss out on the sound for this in here. I don't know if that's a good thing or a bad thing. Oh. Oh. Grandma. Now, if we've got complaints and you want me to turn it off, please let me know. Okay. So yeah, we have, just a reminder quickly, we have the type, the name of the array, which we've, picked a great name array, and then the size of it in the brackets. Now, the people who chose yellow, that's almost correct in some contexts, but the array, C needs to know how many elements there are in the array, and it's not going to know when you do it like that. If you do that and then say equals and have the static initializer and you're initializing it with data, then it just works out the size from that. But on its own, you can't have it like that. All right. Excited dragon, well done. Wow, very good. Excellent. Always naught. And it helps it, we make a lot of mistakes when we forget about that. Okay. If you want to have a bit of a dance to the music, go for it. Yeah, so the program will crash. When you run it, you'll get a runtime error. A logical error is kind of when you try and use an and instead of an or, and you kind of get the wrong answer sometimes. All right. There's lots of different ways to have errors when you're programming, not just, Now these will start getting harder in a minute. Very good, yep. The one at index 0 is a 5. Sorry, if I've gone past one and you had a question about it, come and ask me. All right. Again, people are doing very well on this. Yeah, so the one at index 1 is here. 0, 1, 2, 3, 4. The one at index 3 is here. So we get 6. Good. Okay, I think this one is the one that's kind of cruel. So well done if you got it correct. If you got it correct, did you work it out or did you guess? Worked it out? Yes? Bit of both? Yeah. Yeah? Yeah. I'll show you what's going on. Now, there's a few... Now, I think the first thing that's confusing about this is typically we go to the end of the array, like if these are the indexes, we're kind of not, we're doing indexes that are going to start here and go to here, right? We're going up to index less than 4. Typically we'd go to less than 5. So that's the first thing that makes it confusing. What's the second thing that makes it confusing? Anyone who, yeah. We're doing I plus 1. And actually, once you start doing more problems with arrays, it is common to look at I plus 1. Maybe not in this situation. Sometimes you might be comparing the value at I to the one at I plus 1 to see, oh, are these in order? Or maybe you might want to swap them or something. Here, it was just to, I think, be confusing and tricky. But we start at I is equal to 0. So we're starting here, but we're adding up the one at I plus 1. So we're actually summing up this one, this one, this one, and this one. Okay, we're starting here, but we're summing up the one above it. We move along, we sum up the one, one up from it. We move along, we sum up this one. We move along, we sum up this one, and then we stop. Does that make sense? Oh, so if I'm at I, so I start with I is equal to 0, right? If I is equal to 0, what's I plus 1? But what's just 0 plus 1? Yeah, so I'm actually going to the index at position 1. So my I is 0, but I'm going to this element here. Does that make sense? So you're going, I'm up to here in the array, but I'm going to look at the one next to it, I plus 1. That's all it is. Does that make sense? If we remove the plus 1, what do we get, everyone? If we remove the plus 1, we're just going along and adding up this element, then this element, then this element, then this element, but then we stop. Yeah. Of course, this was, especially with a ticking clock, this one's confusing. All right. I can give you the code later to play around with it if anyone wants. Just ask. Oops. All right, just 2 more to go. Now, look, the way we're doing arrays right now, the answer is false. You can't just return a whole static array. We'll see later that we can return things sort of similar to arrays once we've done something else, but we can't really do it with what we've done. All right. And I'll show you that in a minute. I'll talk about that. Okay, so yeah, this one, I'll explain this one. This one is really testing your understanding of maybe one, how quickly you can read and how well you can see. But apart from that, it's testing whether you understand how arrays are passed into a function and also how all the other types we've seen so far are passed into functions. So let's have a look. Remember, I might just draw this up. So I've got an array called x with these values in there. And I'm passing that into my function called foo. Now, when I pass an array into a function, does it pass in a copy of the array? No, it doesn't. So it doesn't pass in a copy. This x here will be referring to this original array that's living in the memory where all the variables for the main live. All right, I've also got a variable called y that was equal to 0 in the main, and I'm passing that in, and because it's not an array, it gets passed in by copy. So this just gets a copy of the value 0. So in here, this function will have its own y value with 0 in it. Is everyone clear? So because ints are primitive variables, and the way C works, we'll just pass a copy of them. We'll pass the value 0. They've both got their own copy. With an array, they made a decision not to do it like that because sometimes arrays can be really big and it's inefficient. So, and this gives you a nice, easy way to modify your array from outside of a function. So, this means in here when we say x0 equals 99, we're literally going into this original copy and changing it. When we say y equals 99, we're going into our own copy and changing it. All right? So when this function finishes, its variables go because the function's finished and it doesn't, need to waste that memory anymore. And we're left with, 99 here. So this will print out 99. And this will still print out 0. So when you pass in an array, the function can change it. When you pass in like ints, structs, chars, whatever else, enums, doubles, the function can't change it. Is everyone happy with that? Yeah, question? Y is what? Y is x at index 099. Y. That's like that Abbott and Costello routine. Y. Anyway. Y is the y variable 0. Okay. Yeah, it's like a bad comedy routine, right? Asking why, and I'm sorry, my fault. This is why you should name variables with better names. All right, so when we pass things into a function, if it's an integer or a double or a char or an enum or a struct, we get a copy of the value. So over here in foo, there'll be a copy of this variable that gets 0 passed into it, right? But in here we change it to 99. But down here in the main, we've still got a copy that says naught in it, right? So it's like if I had a piece of paper with the value naught on it, and I gave you a copy and you change it to 99, my piece of paper is still going to have naught on it. Does that make sense? It's a copy. Whereas when you pass an array in, it's not a copy. This is just how C works. Okay? Yeah, so that's the design decisions they made when they designed it. All right, so this is a confusing one for sure. If you have more questions, please ask, or we can go through it. Ask me on the break. All right. So let's see who won. And it's not all about winning, because all you get's the chocolate, right? Oh, I thought it was over. One more. Okay, yeah, another tough one because we've only just recently done arrays of structs. So when I've got an array of structs, I'll just go over this. This is part of the recap. Struct coordinate is the type. So usually when you have an array, you give it the type. Often we give it the type int, for example. Here we're giving it this as the type. This is the variable or array name, and this is the size of it. So we've got an array of size 3. But in here, this is just for me to remind you that there's structs. There's structs in there. So if I want to go to the last item in my array of size 3, how would I do that? I would say data at index what? 2. So the last index in my array is 2. So if you accidentally put 3, there's no index 3 in an array of size 3, and that's a common error. So when we do that, that brings us to this actual element in our array, and that element is of type struct coordinate. Is everyone happy up to here? Now, if I've got a struct coordinate, it has 2 values that can be stored in there. We've got an x member and a y member. So to set the actual x member in a struct, what do you use to set something in a struct? Yeah, dot. So we put dot x. So we've got an array. We go to the index to get the struct. We go to dot x to get the integer that we actually want to set. Okay? And we're setting that, in this case, to 9. Okay. All right, any questions about that? So that's going to be really important. Yep?
What happens if you swap it around data.x?
If you do data.x, you're kind of sort of, the compiler might say, actually data is not a struct, it's an array. Do you know what I mean? And if you then try and use an index on x, which is an integer, it'll say x is not an array, it's an int kind of thing. So I guess it's the sort of order it's in is because we've got an array first, so you go to that index, and then at that index there's a struct, so you go to the member. Yeah. So yeah, the compiler will basically complain and go, hang on, this is an array. What's dot for an array here? Okay, so yeah, in the assignment you'll have arrays of structs, so it's really important that you'll know how to access them. All right. All right, now we're up to winners and chocolates. So if you're in the room, just put your hand up to get your chocolates. If you're in the top 3 or 4 and 5, can have a couple of chocolates too. Yeah, if you're one of the runners-up, also you can have some chocolates. All right, I'm going to set up while that's happening for the next part. But thanks for playing. I hope some of those tricky questions helped you.
Sorry, my aim is really off today.
Is everybody safe?
Yes.
Okay. All right. Is everyone ready to just do a quick recap of 2D arrays? Ready or not, we'll be doing it. So, here I've got a 2D array called number grid. That's the variable name. That's the name of the array. And it's of type int. So again, it's an array. We have to give one type for it. With a 2D array, we don't just have one dimension or one size, we've got two of them. So here, the three, we often call these things rows. So we've got 3 rows. And we've got 5 columns. And like always, our indexes start with 0. So if we've got 3 rows, there'll be row 0, 1, 2. There'll be no row 3. There'll be column 0, 1, 2, 3, 4. There'll be no column 5. So when you want to access an individual element, you have to actually give 2 indexes. You've just got to say, here, go to row 2, column 3, and let's put the value 42 in there. Okay. Is everyone happy with that? If I said go to row 3, column 0, what would happen? Crash, yeah. There's no row 3. Yeah, crash. All right. Now, how would I, if I wanted to go through one by one and print out all the data in this 2-dimensional array, imagine there was data in all of it. A common way to do it would be to start at row 0 and go along column by column by column by column. Okay? And to go along the column, it's just like looping through an array. You start at column 0 and go through to the end. But now we have to do that again and again and again for every row. We go then to the next row, start back at column 0 and go through one by one. When we finish that, we go to the next row, go through one by one. So to do that, we've been using nested loops, right? So we'll do that, and I'll show you just another example doing something similar. We're going to copy a 2D array, and then we'll go and do the diagonal question we looked at that we didn't actually finish. So here's this thing we're working on before. Here's a 2D array, and I've given it some values, and you know, here we've only got, I'll just draw it in here, right? It's got row 0, row 1, columns 0, 1 and 2. So these are the rows and these are the columns. Like sort of how I've put them, how I've typed them in it, you can visualize it. Now to print it out, oh, that's going to move. To print it out, yeah, we've got this thing where we're going through it. Kind of what I just sort of said, we'd be starting at row 0, and then we go to col 0, and we print out what's in there. We increment col, we print out what's in there. We increment col, because like this is a loop. We print out what's in there. Now when this counter gets to 3, the number of columns is 3. 3 is not less than 3, we stop. We've done a whole row, and we print out our new line. Okay? Then we're back to here, we're incrementing our row, and we do it again and again until we've done all the rows. Is any questions about that? You could also do it with while loops. All right. How's everyone going with that concept? All right. So what I want to do now is we did sort of a row sum, col sum, sums. I might just get rid of this for now. Just so it's not as cluttered while we're doing other things. Okay, so at the moment, quiet when I'm trying to type and not typing very well. Okay, at the moment, all it's doing is calling that print function. And when we're passing it in, I'm just making it easy. We're only writing code for grids of this particular size, like particular dimensions. All right, now, what if I want to make a copy of this grid? Now, I could try something like this. Oh, I should give it a different name, right? I'll call it grid 2. Now, can I do something like this? Grid 2, I'm giving it the same dimensions, equals grid. So if I had int x, I could make it equal to y, right? Very easily. Can I do this with an array? No. It doesn't let me. Let's try it. Array initializer must be initializer list. Yeah, you can't do it. I can either, if I say equals, when I declare it, I could type in exactly the same thing, but I can't just, which I wouldn't want to do for a big array, right? I can't do something like this. How could I do a copy of it? I have to create my own copy. So I've created the variable that I want to put it in, but now I have to move everything into it. So imagine I just did it here. Forget functions for the minute. I've got my grid with my values in it. I've got my new grid, grid 2, that has nothing in it. How am I going to copy all of these values into this grid? Yeah, so I can just do pretty much the same code with a loop like I did to print it out. Who wants a for loop? Who wants a while loop? I think I heard more fors. So I'm going to start, let's call it rows and cols. So I'm going to go through every row, one by one, but every time I go through a row, I have to go through every column. Right? And this is just so typical of what we might do if we're going through everything in our 2D array. It's just, what are we doing? Well, this time, we're trying to set the values in grid 2. And we're saying, okay, grid 2 at index row col, I just want that to be equal to what was in my other grid at exactly the same location. Right, so we're starting here, we're getting this number out of our first grid, and we're just putting it into our second grid at that same location. And we're moving along, doing that one by one. We do one whole column, and then we move to the next row. And we're just copying it over one by one. Okay, by the end, we've got a copy. Let's just see if it worked. We're printing grid. We can also try and print our other grid. Uh-oh. Oh, what was I doing? What have I done? What should I do? Yeah, I didn't initialize it. Yeah, I didn't make it equal to naught. I don't know why. Just sometimes you just do things wrong. Okay, so that worked. Now, what's wrong with, well, there's probably plenty of things wrong with my style, but what could be done better about this chunk of code? Yeah, I could put it in a function. Now, how am I going to do that? I'm going to call it copy grid. But what's my return type going to be? How am I going to do this copy? Can I just pass in my original grid?
You can use gal or int. Use int or gal. Maybe
I can use,
int.
well, but am I going to pass in the original grid and then return the copy? Can I return an array? No, I can't. I can't do something like and return an array. So it's going to have to be void. But what I'm going to have to do, and this is typically what we do, I'll call this grid copy. I'm running out of screen space. Let's put it here. Oh, I'm missing this. So, oh, and this is supposed to be the prototype, not the whole function. And I've got too many brackets here. Okay, good. So what I'm doing is I'm passing in both arrays. I'm going to pass in my array grid, which has all the data in it. I'm going to pass in my other array when it still doesn't have data in it. In the function, it's going to go and just copy them all across for me. So let me write the actual, I'm just going to copy and paste this and actually write the code here. It doesn't like what I've done with my spacing. Oh, I'm just going to put it up here. All right. Yeah, so basically I'm just moving all of this into here. Now within this code, I've given it a different name. I've called it grid copy. So when I call the function, I'm going to say, please go and copy this grid. I want you to copy all the data from the first one into this second one here. And this works because when we pass things in, if they're arrays, when we pass this in, this is really getting access to our original array, which it doesn't really matter so much here. But it's also getting access to this actual array here as well. All right, so we've got access to both of the original arrays. So when we copy over the data, it's copying it into this array that lives in the memory in the main. Okay, does that make any sense at all? And this is the way we're going to be doing things with arrays. If we need to change an array or modify an array or even initialize data in an array, we'll create our array, get the memory for it, pass it into the function, and then the function can go and fill it up because we can't return it. Let's just check it still works. Woohoo, it does. Amazing. Any questions before we look at diagonal? Yep.
Can you do the same thing where copy grid, it's not void but returns grid itself?
It can't return, we cannot return an array from a function, so we can't do it like that.
I mean,
Yeah, so we can't, what people are going to want to do is create an array in here. This is what everyone's going to want to do. And then like return it. Who 100% just wants to do that? You think, I've got to create a copy of this array, I'm going to create it, I want to return it. Unfortunately, we can't do it like that. We have to make it in the main, pass it in, and then this function can go and fill it up for us. All right. So we don't need return in this function because it's a void. Okay, so let me just define this again. So here we're passing in, change everything. We're passing in 2 grids, we're not returning anything. So this function doesn't return anything, but it's got like a side effect, or it's something that does, it modifies the values in that array that was passed into it. The array gets passed in and it's never the same again, it's changed, right? And we don't need return unless we're returning something. Like here we returned an integer sum. I asked, what's the sum of all the numbers in this grid? And it returned me an answer of, I don't know what it was, 40 or something. Yep. Not with this. If we want to return something, like an answer that we're going to use in our function, we've got to return it, but we can't return an array. All right, let's do another example quickly and then we'll move on to something else. Did anyone do the other diagonal? Did anyone look at this? So we noted the other day, if we were wanting to look at the diagonals, here we noted that it's at 0, 0, 1, 1, 2, 2, and 3, 3, the indexes. And we wrote code that made use of that. It did, where is it? Here. If the row is equal to the column, it's part of our diagonal and we want to add it to the sum. Now, did anyone work out what the pattern was for the other diagonal?
Yeah, like inside the column group, if the column is equal to the size minus row minus 1.
Yes, that, yeah.
Can we do row plus column equal to 3?
Okay, so
You can do size minus the height value there.
so I had a lot of good ideas here. I'll just go through them. So here, if we look, and I think they're all basically right. Over here we've got, this one is at index what? 0, 3. This one is at index 1, 2. Oh, I can't. 2, 1. Oh my goodness, my brain, why won't it do it? 0. So, yeah, I mean, basically, if the row and column add up to 3, but what's 3? Size minus 1. So it's like looking at the pattern and trying to see if there's any kind of formula for this. And that's one way we could do it. So does everyone agree these all add up to 3? And 3, why 3? It's size minus 1. So let's just quickly, I'm just going to copy and paste this. What did I just say? Row plus col equals size minus 1. Let's try it. And while I'm doing this, think about what the answer should be so I don't have to try and add it up. Okay, so I think that's correct. All right. So that's just a bit of a recap on 2D arrays. Hopefully they're going kind of okay. We're going to look at something different, but I think we should probably have a break because it's 5:02. We're going to look at strings. All right, so yeah, we'll come back at about 5 past, but we'll try and come back. We'll try and come back and start exactly on time. All right. Let's get back to it. So we're going to look at strings now, which is amazing because, yeah, I mean, when you go and look around, when you're using computers, lots of things are text. You'll see text everywhere, and we haven't had a way to store any text. We've been able to print stuff out, but we couldn't store it in a variable. So that's what we're going to be able to do with strings. Okay, so in C, there's no type called string. So you can't say, you know how you can say int x, int double, whatever. There's no actual type called string, but strings are collections of characters. And we do have a way to store collections of characters because an array is a collection, an array of char is a collection of characters. So we can store text or words or strings in arrays of characters, but a string is not just any array of characters. It's got a special character called the null terminator. So the null terminator tells us where our string ends. So, you know, if we're trying to read in integers, integers all fit within one type of 4 bytes. If we're reading in strings, if we say, you know, type in your name, we have no way of knowing how many characters are going to be in somebody's names, right? There's such a variation in how long different words are, how long different pieces of text are. There's no uniform length. So instead of having to have variables to keep track of all the lengths of all of our different strings, where they're all going to have different lengths, if I put everybody's names, try to create, you know, variables for everybody's names in the room, you'd all have different length names. So in C, they decided to just put this at the end of the string to show you that that's the end of the string. And whenever you get to this character, even if the array is bigger and there's more data, anything after that is not considered to be in the string. So a string is an array of characters that ends with this special null terminator. Everything before this is considered to be part of the string. This means if I want to store hello, which is actually 5 letters, I actually need an array of at least size 6 to store it in. So we've got this extra storage cost of 1 byte for that null terminator in our strings. Okay, so that's kind of a string. That's it, right? And the key is if we're printing out hello, we obviously don't want to print out this weird \o, right? This isn't something we print. It's not part of the string in terms of what we wanted to store. It's just this extra thing for C. We don't want to go printing that out. It's really useful once we start doing loops throughout our array. We won't know the size of the array, but we'll keep checking. Is this element that I'm looking at, is this equal to this null terminator? No. I know I'm not at the end of the string. You know, as I go along, I get to here and I think, is this equal to this null terminator? Yes. And I know that I'm at the end of the string. So it helps us know when we're at the end of the string. Okay, I think I've said all of that. Now, how can I actually create these or declare and initialize string variables? Well, yeah, it's like declaring an array, and I can do it like this. Just like when we have integer arrays, I can use these wiggly brackets and hard code in each character. I have to, because I'm using characters, I have to put them in the character quotes, as always when I'm using characters. And then I have to make sure I don't forget to put this null terminator at the end. If I forget that, it's going to break anything that relies on that being there, which is a lot of stuff. Now that gets really annoying really quick, but that really shows you how it's represented. The more convenient way, because strings are so common, is to use these double quotes. And we've seen these already, right? So we've printed out hello world with these double quotes. So what you were looking at was like a string literal, but we haven't had a way to store it in a variable yet. So if I declare it like this, behind the scenes, it's doing the exact same thing for me. It's just making my life easier. It's going and putting all the letters into the array, and it's adding this null terminator at the end for me. Okay? So even though you can't see the null terminator when we do it like this, C puts it in for us, and then this is the easiest way. Right? Note, I haven't put the size in here either, because I don't trust my ability to count the letters properly. Like for general, hello maybe I could do. But generally, if you've got text, you don't want to be counting through the letters. Go, size 32 array. Now, C can work that out much, more efficiently and effectively than I can. And it'll put this in. So, yeah, we don't tend to do this in practice much. We tend to do things like this. How do we print them out? Well, they are arrays of characters, so I can go through one by one. So I could start with I is equal to 0, and I go and check. I go to my array at index 0, and I check if this is equal to this, and it's not. H is not equal to that \O. So I print out my H, and I increment I, and now I'm ready to look at this one. And I print out the E, and I go through it along one by one in a loop. When I get to here, I go to the word at index 5, and I see this special end of string null terminator, and it's kind of like a stop sign saying stop, that's the end of the string. And then my loop stops. So it's pretty similar to going through an integer array and printing it out one by one, except we don't know the size. We stop when we see this item in the array. Are there any questions about that loop? Yeah, oh, there's a question right there in front of me.
It's not really about the loop, but when you make the string, you don't have to put like a number after the word, like in the square bracket?
No, so you don't have to put that number there. If you're initializing it with data, if you're not, if you just said, I'm going to declare some string like this, no, that's not okay, or with an array, because they have no idea, C has no idea how big you want this array to be. You would have to put in some sort of size in this instance.
But if you do it like that, doesn't it just fill it with numbers?
If you do it like this, you'll just get a chunk of memory that's not initialized.
Oh.
And that's fine sometimes because you might be doing something with it later. But if you know what it is, you don't have to say how much memory you want. It can work it out for you. There might be cases where you want to make it bigger. I might make this size 100 because even though I want to store hello now, later I might change my mind and change it to goodbye or something. Sometimes you make your strings bigger to have capacity for later. If you just want it big enough for that current word or whatever you're doing, just leave it out the size because you'll get it wrong. I mean, I get it wrong. But if you're printing out a string, which is done all the time, we don't have to write that loop. But sometimes there are times where we do need to look through a string, and we'll do it in a similar way. If I'm just printing out a string, I can use %s with printf. Okay? And that's easy. Did you have a question?
Yeah, so what if you declare, so you type this in array, int array square brackets nothing inside equals to curly brackets nothing inside. What memory does that create?
Oh, so the question was, if we do something like, let's just go back to int. Oh, nothing inside here.
And then equals empty.
Yeah, well that wouldn't be good because I don't know that they'd be happy about that. Like C is some organization. It does compile.
Yeah, so like what
It'd be like empty array with nothing in it. Yeah, it'd be an empty array with nothing in it, I think. Yeah, I've never done it, to be honest. Give it a try. I will work this one out later. Yeah, very interesting question. An array of size 0. Yeah, that's what I thought. But you can't really do anything with it. So it's not useful to do it. Yep. But yeah, if you do it by accident, you might get some very confusing error messages. All right, is everyone, let's just do some simple coding with strings. I warn you, this is just showing you the concepts of strings. It's not really doing anything particularly useful, this program, I'll be honest. I've declared 3 strings, all right? The first one I did the difficult way. Favorite food, KFC, it's true. Not that it's a true or false game. Favorite drink, I've put kombucha, but I've done this the easy way using the quotes, right? But it's still going to lay out an array. Actually, let's think about what these arrays look like. So, favorite food. I'm not drawing all the character quotes in. It's going to look like this. So I need an array of size 4 to store this 3-letter word. If it's a word, yeah. This will be a size 9 array to store an 8-letter word. Okay, good. Now, the other one, what have I done for the other one? I've made a string called favorite book, and I've set it to be of size 100. I'm not going to try and write in all the indexes for this one. And at the moment, it's got uninitialized data in it. Now, if I want to try and set my favorite book or a string like this, after I've declared it, it's not going to work, right? This is like if I've already declared an array and I try and make it equal to another array, it doesn't work. So if I try and do this, I've created an array for my favorite book, and it says no, it's not assignable. Right? We can't do this with arrays, just say this equals this, except when we're initializing it. I'll show you what we can do later. But so I'd have to put it up here. All right. Has anybody read that book? It's a kid's book. Oh, I've deleted. Oh, I've still got this one that I can't do. All right. Now, I can go and get individual characters from my strings. So if I went to favorite food at index 0 and printed it as %C, what would I get? K. Yeah, so favorite food, this is the string, index 0, it's going to give me a K. If I went to favorite drink at index 3, yeah, so remember, this K is index 0, 1, 2, 3. Let me bring my picture back. Yeah, 3, I'd get the B. So I can go to the character level in these strings, or I can do things at the string level. I can just do %S and print them out. Let's just run this. Yep, it's printed out K, B, KFC, kombucha, folk of the faraway tree. All right. Now, we can also modify these strings. So imagine I just go to favorite drink at index 0 and change it to Z. So I just go in here, go to index 0 and change it to a capital Z. If I print that out, what am I going to get? I'll get rid of this now. What am I going to get? Oh, I've just started typing it in. Yeah, doesn't mean anything, but I'm just showing you can modify it, right? What do you think I'm going to get if I do this? Favorite drink at index 4 equals the null terminator. Mind you, I've already got a Z at the beginning. Yeah, that's right. So I'm going to get, at index 4, if I go and put this, oops, sorry. If I go and put this at index 4, this null terminator, that means anything after it is considered to be rubbish and not in the string. So it's a way of kind of chopping off the end of my string, right? So now I'm just going to get zomb. Is everyone happy with that? As soon as you get up from the beginning up to that null terminator, that's what's in the string. So if I compile that and run it, yeah, I get zomb. All right. Yep.
Can you store spaces?
Yeah, you can store spaces. Like folk of the faraway tree, see, that's got spaces in it. Yep. And you can just have spaces, tabs, new lines. Yep.
So if we add the null operator to any element of our string, so our string just goes till there and then stops?
That's right. If I put it at the beginning, I would have what we call the empty string, a string with nothing in it. Okay, so I can have a variable like this. It would be an array of size 1, and all it contains is that null terminator character. All right. Yeah.
So if we put this into like a while loop that prints out every letter, right? It will technically stop itself even if we don't put anything to stop it. Does that make sense?
Well, if we put it, we looked at how to write print string. Let's just write it again ourselves. I've got a function here. We can do our own version of printf %s basically. But the way we write it, just to remind you, now we could do it with a for loop or a while loop because they're pretty much the same thing. Instead of saying something like I is less than size or something, we don't know a size. So I've called it S. So basically this is what I'm trying to do. I don't know a size, but in this loop, the logic I use is if the element that I'm currently looking at is not equal to this end of string terminator, null terminator, I keep going. When I get up to it, I stop. So this logic is built into the while loop or the for loop condition to stop when we get there. And that's how printf %s basically works as well.
What I wonder is that if we put no conditions in the while loop, will it like keep on printing until it reaches the null? And after that stop itself? Or
Yeah, so if we, I'll show you this now actually. Let's go up to here and delete this. So I don't have a string. I've got an array of, the question was, basically, if I don't have a null terminator, if I don't check for it, what's going to happen? Will it keep going forever, trying to print stuff? And the answer is yes, it will, but DCC will stop us, right? So anytime, it means we'll probably end up going over the end of the array, or we might end up printing out garbage, just random weird characters, or, I mean, if we're going past the end of the array and writing to it, we could be overwriting memory. But DCC will usually pick us up on a lot of those things. So let's try it. I've left out this on purpose, and I'm trying to pass it into something like printf%s, which is looking for that thing, and a null terminator. Yeah, and DCC is going to crash because it's going to print out K, F, C, then it's going to move past the end of the array, and DCC is going to stop us. If we were using a different compiler, it might just keep printing out all sorts of stuff. You'd just be getting all the text from your program, and then eventually it'd stop or crash. Okay, so yeah, and we're not going to do that on purpose, but if we accidentally do it, or you could be manipulating your string in some way and accidentally overwrite it yourself by accident. All right, oh no, that's okay now. Let's put that back. Oh, I think I've done all the stuff. Oh, let's just check our own print string works. Yeah, it printed out KFC. I didn't have a new line character to print. All right. Now, the next question I know that everybody's thinking is, how do I read them in? Was anyone thinking that? And what's the way that you'd imagine we'd read them in? So maybe we could read them in character by character using scanf%c. Did anybody think maybe there's a scanf%s? Because there's a printf%s. Is there a scanf%s? There is. Unfortunately, we don't let you use it in this course, just to make it harder. No. It's illegal in this course. Look, if you just use %s as %s, there's no way to tell C, there's no way to tell C to stop reading. Like, I've got an array of size 10 and a user's typing in 100 characters, and scanf is going to try and read it in, and it's going to crash your program if you're lucky, or hackers can use that to try and hack into things. And it's a security vulnerability. So we don't want you to use it. And even if you try and use it, it might not do what you want it to do. So it's going to stop when it gets to a space. So if you're trying to type in your favorite book, The Folk of the Faraway Tree, it's just going to get it's not going to get the rest of it. But you'll lose marks if you use it as well. So how do we want you to read in strings? There's a function called fgets. And you're really going to want to use scanf%s because it's going to seem easier. But this is what you're going to use, and it's better, and it's fine once you get used to it. So you pass in the actual array or string variable that you want to read it into. You pass in the size of it. So if your array is size 10, you're passing in size 10. And fgets is just going to read in, and once that array's full, it's going to ignore whatever the person's typing in, which might sound bad, but we don't want them to be able to crash the program or overwrite memory or hack in. So it's good. And in fact, it even knows about the null terminator. So if it's size 10, there's someone talking, yeah. If it's size 10, it'll know, oh, I can only read in 9 characters because I've got to put that null terminator at the end. Okay. Then there's this weird thing. So when you go on to further subjects, you can use fgets to do other things and read from files and stuff. In our course, we're using it to read from the terminal or standard input. So we always literally just type in standard input in this third thing in this course. Okay. Now, I'll show you in a minute, but when I call fgets, so if I do one call to fgets, it'll read in characters until basically the array is full. So somebody's typed in size -1 characters, or they press enter, which gives us a new line character. It'll stop if it gets a new line character. So if I just type in dog, enter, it'll stop, even if the size is 1000. Or also, we've seen this a bit. You can press Control D and it's quite a standard way to signify that there's no more input. So if a user doesn't type anything and they press Control D, that will also do our one call of fgets and stop it. Yeah, there's a matching function called fputs that you can use to print stuff out. I don't think it's necessary for this course, but you might see it. But don't worry too much about it. So we've declared our array, and because we're not actually initializing it or hard coding it with, a string value, we're just giving it a max length. So imagine we give it a max length of, of 6. So we get an array big enough for 6 characters. We call fgets, we pass in the array, we pass in the length, and we say read it in from standard input. Now if the user types in hi, they're going to type in h, I, and then they're going to type in enter. And we know that enter gives us a new line character. So what will end up being stored is h, I, new line. That's what the person typed. C will put this null terminator in there for us. And in this case, we'd have some spare room at the end that we're just not using. And that's typically what we have to do because we can't read people's minds. If we knew what they were going to type in, we could hard code it in ourselves. We don't know what they're going to type in. Typically, you'd make it bigger than 6, right? If you don't know what someone's going to type in, you might make it size 100 or something. All right, so let's just play around with it. So I've declared a string variable called movie, and I've given it like a max size of 20. I'm going to read in the name of a movie using fgets. So I've got to put the name of the array, the size of the array, and this new word that we've seen today, stdin, which means I'm just typing in by default on the keyboard. Once I've done that, I'm just going to print it out using %s. All right? Oh. Don't worry about ctype.h for now, but we will talk about it in a minute. Okay, so if I run this program, it's waiting for me to type in my favorite movie. Who's got a favorite movie? The B movie. Is it called the B movie? Yay! And I thought you were all going to say Barbie, right? No, I don't know. All right, so the B movie. Now, does everyone see that I've got this extra new line character? Because remember, it's fgets reads in my new line character. Unless the string is too long. So imagine I start typing in, I don't even know, Harry Potter and the something or other. That's not going to fit because my string is only size 20, right? I think that's more than 20 characters. It's just going to stop. It's going to be responsible and say, enough's enough, the array's 20. I've already got 19 characters. I need the null terminator in there, that's it. And it just leaves the rest there. Now, the rest of that string, so we've heard about the scanf buffer, but it's basically an input buffer. The rest of that string's there. If we did another fgets, we'd get the I don't know part, right? But anyway, there were a few hands up. Yep.
Is there a way to remove the new line created? Because I feel like it's going to be a problem.
Yeah.
Other than like using a loop to check and then manually change it.
So we had a question. How do we remove the new line character? Is it going to be a problem? Yeah, it gets annoying, and I'll show you that later. I'll show you that in an example. Yep, you can do a while loop to search for it and get rid of it.
Is there a faster way?
Yeah, I'll show you another way if it's just one at the end. Yep. All right. Now, if I want to read in more than one movie and print it out, I can. I can put this in a loop. And I don't know in advance how many times I'm going to do it, but fgets will return null if we do a control D. Whatever that means, it doesn't matter. It's just a way of signaling stop your loop. We've got a control D. So this allows me to keep reading in lots of movies. I can't. And you can see here, typing in that it's gone through the loop twice. I typed in one string. The first fgets read in this much and printed it out. And note, it didn't read in a new line at that point. It hadn't got up to that, so it doesn't have it. And then the next call to fgets got the rest of it. So you can get all the user's data, but you might not get it all in one chunk if your string size isn't big enough. And now I'm pressing Control D. How many strings did I actually store in this program though? I had one variable and I read Star Wars into it, but then I overwrote it next time around with the B movie, and then I overwrote it next time with Harry Potter and TH, and then, you know, I had one variable, I kept overwriting it. If I wanted to store more of them, I would have to have like an array of strings, which we will see as well, but not yet. All right, now imagine, or I guess not imagine, let's write a function that can change all of our letters to capitals. Why am I going to do this? Just as an exercise, and also, yeah, I was going to show you this library. We're going to start now. In your tutorial, your tutor might say, let's do this ourselves without using the library function sometimes. But other than that, here's a link. There's more functions in that library that can make your life easier. Now, you all know how to convert to upper and to lower yourselves, but sometimes it's nice to just use these functions. But you don't have to. All right. So we're going to write a function. The input is a string, and we're just going to convert it to all capitals. So I'm going to read in my movie. I'm going to pass it into this. It's going to turn it all into capitals, and then I'm going to print it out again. Why? Just because it's an example. All right. So in this situation, imagine I've read in my movie Star. Let's just call it Star. My favorite movie is Star. I just want to go through character by character and convert them all to uppercase, right? So I'm going to have a loop that starts at index 0, the beginning. And when do I finish my loop? I want to go through every single character in my string. Yeah, so this string, in this function, we're going to call it S. When we get up to this particular piece of data, we're stopping. Okay, so while S at index I is not equal to this null terminator. And at each point, I just want to modify that character. So I'm going to say S at index I equals, well, I want to convert it to uppercase. Now, I'm not going to do it myself. I'm going to use this function called toUpper, just so you know it exists. I'm going to pass in my character. It's going to convert it to upper, and I'm going to store it back in my array. And it's complaining because I deleted that line that said, let's include that other library. Okay, so I'm including that new library we just learnt about today. So now, what have I forgotten in my loop? Yeah, I haven't incremented my counter. Oh, let's just type in star. Woohoo, and it's going star. So it's just to introduce you to the C-type library and just to go through a string, but also to show you how I can pass in this string into a function. And notice in this function, I don't have a size here because I'm not actually declaring a new variable as such. I'm passing something in. And the function will work out when it gets to the end of the string because of that null terminator. It's not like an array of integers where it has to be told the size. Oh, any questions about this? Probably lots, but let's take a few. Yep.
With the new library, is that like allowed for like tests and everything, or just more for our convenience?
Basically, you're allowed to use it. Sometimes it might say you are not allowed to use it. If it doesn't say that, then you can use it. Yeah. Yeah. Yeah, so unless the activity specifies, if it's one of these sort of standard types of libraries, especially ones we show you, you can go for it. Sometimes in your tutorial, your tutor might say, let's just do this ourselves as an example. And now we're going to show you another library. And this is one that, I've done this. This is one that can help you with strings. Now this is one you'll definitely be wanting to use. You can find the length of a string. You can copy a string. You can compare two strings. You can join two strings together. You can search for a character in a string. Now these are all things you could write your own loops for, but they're things that are in a library that you can use. And string length is pretty easy to write yourself. Even string copy is not so bad. But some of them get a bit tricky actually, and it's nice to know that you can use it. It's been debugged. It's not going to be a source of bugs in your code. Whereas if you write it yourself, that's always, a possibility. So let's just have a quick look into these functions. So, okay, I've got this in code. I'll go straight to the code. So first of all, I'm including this string.h library. And first of all, I've got an array of size 100. We typically waste space when we're doing strings. We make them bigger in case. Now originally, remember this array is of size 100. Originally I've put the name boots in it. Right? And I've initialized it with that. Now later if I decide, I wanted to call it something else. I wanted to call my puppy something else. I can't just say, as we sort of already learnt, we can't just say puppy equals some other name. Okay? We've got to copy it in. Now we could copy it in manually with a while loop, or we can use this string copy function. Okay? So I've got my array that I'm going to copy something into. I've got the string I want to copy into it, and I'm giving the max size of this array that I'm copying things into, right? So I'm putting the letters. This is going to go and copy over what's in this array already. with fin, right? So it's actually copying over this. And it's making sure that if I put some really big long string, it's going to cut it off and not overfill the array, right? So that's why we put the length in. We're saying at most 100 characters can go in this array. I want you to try and copy this string into it. Does that make sense? So we're just copying it in, and it's just looping and putting those characters from that string into the array. All right. Yep.
Would boot still be the array?
No. So we've got one array. I'll just do it again. I'll try and be a bit neater. So it'd look like this, but be bigger. No, it's going to copy them in one by one. So instead of having a B there, it's going to have an F there, an I there, an N there, an N there, and then the new line there. It's going to destroy what was in there. Okay. Yeah?
So would the slash O still be there? Like, would there be two slash O's?
Yeah, but after that, after the first slash O, so the question was, will there still be stuff left in the array? Yeah. But once you get to the first slash O, anything after there doesn't matter. It doesn't exist anymore. Like it's not part of the string. You can have all sorts of stuff in there, it doesn't matter.
But in the string, there would be still two slash O's, right?
Yeah, there'd be two slash O's, but after the first slash O, nothing else matters. Yeah, nothing else matters. It's like it's just garbage that doesn't exist once you get to that first slash O. So you can have whole sentences still in that array. Once you get to that first slash O, they're not part of the actual string. Okay, one more question and then we'll move on. Yep.
How would you go by doing from boots to FI and the S exists over there?
That's when, so the question was, how could we have fin and boots? That's when we do something like join two strings together.
No, I mean not boots and then fin, like fin takes over, but the remaining S stays there without replaced by the /0.
That's when, so the question was we might want part of one string and part of the other. Yeah. That's when we need to do something trickier than this. So we'll do an example like that where we're mixing strings together, but not yet. I just want to focus on some of the basics. So that's string copy. Then we've got something to find the length of a string. So if I'm asking for the length of the string fin, it'll be FINN 4. It doesn't include the null terminator in the length of the string. All right. The other thing, let's quickly run this. Yep, so the string did have boots in it. Now when we print it, it has fin, and it says it's a length 4. It doesn't include the null terminator in the string length. The other thing we can do is compare two strings. So now I've got another variable called name, and it's got Oscar in it. I'm now comparing the string Oscar to this name. What's in the name? Oscar. What am I comparing it to? Oscar. Are they the same? Is Oscar equal to Oscar? We're comparing them. Yeah. We're wanting it to say yes, they're the same string contents. The contents of these strings are the same. And we can use string compare to do it. Now, if the strings are equal, it returns 0 to say there's no difference between the strings. If it returns a negative number, the first string is less than the second string. If it returns, what did I just say, a positive number, the first string is greater than the second string. What does that even mean? A string is greater than another string, or bigger or smaller? It's kind of, yeah, sorry? Yeah, I guess the ASCII value, so it's sort of like a dictionary comparison, right? And especially because the ASCII characters are in order. So, you know, if you have the string that starts with A that's going to be considered to be smaller than a string that starts with Z, right? So it sort of does that kind of comparison. But then there's capitals and lower cases. Anyway, so we're expecting Oscar to be equal to Oscar, and it's going to return 0, and they're going to be equal. Yep.
If the number of characters in Oscar and Edgar is different, like instead of Edgar, it's something with 6 characters.
Well, it doesn't. This is a good question. What if there's different numbers of characters in the string? As soon as I look at, with Oscar, I have to compare every character in the string. If I get to the end, well, I don't, string compare does it. If I get to the end of the string and all the characters were the same, it's the same. If we're comparing, in the next one, we're comparing Edgar to Oscar, I mean, I only have to look at the E and the O, and I already know they're not equal, and I already know that E is smaller than O, right? So it's like in a dictionary, kind of, when you look in a dictionary, how that order would kind of go, kind of. So yeah, basically compare will return an integer, and you look at that integer and you can do if statements to work out whether that meant they were equal to, greater than, or less than. So yep, it returned 0, Oscar equals Oscar. It returned a positive number because Oscar is greater than Edgar. Okay, so that's just another function that you're able to use. Now, let's look at this last example here. So this is saying you can go and enter the name of a city, and it's checking to see if I enter Sydney. So I'm going to enter Sydney, right? And it's checking if it's Sydney. What's gone wrong? I've compared it to Sydney, I typed in Sydney, and it's not saying it's the same.
Enter.
Yeah, it's the new line character. Who said that? Yeah. Then that's exactly what you were predicting before. This new line character, when we use fgets, it can sometimes trip us up because I haven't just typed in Sydney, I've typed in Sydney, new line. And we can see that if I compared it to Sydney, new line, it goes great. But you know, sometimes you actually want to get rid of that new line character. How do we do it? Let's work, imagine I typed in dog, just because that's such a small word. All right, what's the string length of dog? New line. So what we do is we count all of these ones, but we don't count that in our string length. So our string length is 1, 2, 3, 4. Now, if we've got a trailing new line that we want to get rid of, it's going to be in this position here, right? At the end, just before the null terminator. So what would that be in relation to our string length? Yeah, so no matter what our string is, if we've got a new line at the end, it's different if we've got new lines all the way through the string, but if we've got one at the end we want to get rid of, it's going to be at string length -1. So what I can do, and this is common, I can just check. What if we don't even have one there, right? So I can say, if my city, actually I'm going to use string length first. I think I've already got a length variable. I don't have to declare it again. I'll get the length, and then I'll say, if I go to that character, and it actually is a new line character, I want to get rid of it. How can I get rid of something?
Into a null terminator.
Yeah, I can turn it into a null if it's at the end. That'll just chop off the end of the string. Let me just bring it back. If I change this to a null character, my new line problems are gone. I've just got DOG null terminator. So this is a common trick to chop off a trailing new line character. I haven't finished though, right? -1. I just set it to this. And now my new line's gone, and it'll be able to work out if I just type in Sydney now. It should recognize it when I do a string compare. When I print it out, it doesn't have that extra new line. This is a common thing to do. Just get rid of that nuisance new line if it's there. And you could do it using your own loop, but if we've got string length, it's really handy for this situation. So that's pretty much it for strings. Let me just check. Yeah, arrays a string in command line arguments. I will do that in the lecture recording that I post instead of Monday, right? I'll do those topics and I'll do an example, a larger example with a 2D array of structs and multi-files. Wow, it'll be a lot. But have a great long weekend. And oh yeah, as always, please, feedback is welcomed. And yeah, have a great long weekend.
So there's this part where you had a while loop, like you had this condition, as long as it's not equal to null, and then you're taking in like strings.
Yeah.
But my question is, the part where it printed this part of the string.
You take any point.
Why did it print this?
So what happened was I did fgets and it could only read in a max of 20 characters. So it read that in and it printed that out. But we're in a loop doing fgets.
Yeah, it continues.
And it continues.
It's not null.
Yeah, that's right. And all of that stuff is still
The thing
sitting.
is, it's not stored in the array.
No, but what happens when you type stuff into input,
Yeah, bigger than the size, the maximum size.
it's even like when you're typing in integers, you might type in 10 integers in a row and your scanf might read one of them in at a time because
so it reads them all.
it's got an input buffer.
Yeah, the buffer.
So the system will keep track of everything the user's typed in.
But is this part of the string stored in the array though?
What I'm printing out is the user typed in Harry Potter and the I don't know.